Okay, in this video, we're going to talk about parallel lines and different types of angles within parallel lines. Particularly, this section is about starting with lines that you know are parallel and determining what you can say about the angles from those lines when they're cut by what we call a transversal. Now, a transversal is just a fancy name for a line that goes through other lines. That's what a transversal is. And in this particular case, we're talking about parallel lines. Now, what are parallel lines? Parallel lines are lines that never cross. They never cross, extend forever, and yet never intersect. That's what parallel lines are, and that's what we'll be talking about in this video. So let's just look at this first reason, maybe. If two parallel lines are cut by a transversal, so we know that these two lines are parallel. We're told that. And that's what these arrows mean right here. If you ever see arrows like that on two lines, then you're being told they're parallel. Other than that, you can't assume that the lines are parallel unless you're specifically told or you see these arrows on the lines. Okay, so if two parallel lines are cut by a transversal, then corresponding angles are congruent. Well, what are corresponding angles? A way that I like to think about it is if I were to draw a box around each of these points of intersection, within these two parallel lines, the corresponding angles would be the angles that are the same, that would be indistinguishable if you only looked at that box. So for example, let's look at, if I call this angle 1, 2, 3, 4, and then maybe I call the angles in this box 5, 6, 7, and 8. Well, these parallel lines have been cut by the transversal, and so the corresponding angles are congruent. So angle 1, and I'm going to write this out for the sake of my colors. Okay, these are all congruent to certain other angles. So if I were to look at this top box and this bottom box, what would be the angle that's the same? Well, angle 1 and angle 5 are in the same position, so they are corresponding angles, meaning angle 1 is congruent to angle 5. In the same way, angle 2 is congruent to angle 6. That's not the best 6 I've ever drawn. It's okay. Angle 3 is congruent to angle 7, and angle 4 is congruent to angle 8. So that's what we're saying. If I have two parallel lines cut by a transversal, then the corresponding angles are congruent. Let's look at some more angles that we can talk about being congruent with parallel lines. Okay, if two parallel lines are cut by a transversal, just like last time, then the alternate interior angles are congruent. So maybe I just want to kind of keep up my numbering from last time. So this is 1, 2, 3, and 4, 5, 6, 7, and 8. Now, alternate interior angles. Interior angles are the angles inside the parallel lines, the angles in between the parallel lines. So in this case, that's 3, 4, 5, and 6. And alternate interior angles are on the opposite sides of the transversal and made with opposite parallel lines. That's why they're alternate. So in this case, my interior angles, we already said were angle 3, angle 3 and angle 4. And those are congruent to the alternate interior angles, which are angle 6, because angle 3 and angle 6 are completely opposite each other right there. Not only are they on different sides of the transversal, they're made with different parallel lines. And angle 4 is congruent to angle 5. And this makes sense with our last, and I would say really that first, talking about corresponding angles will help us prove everything else. So if we can say that the corresponding angles are congruent, then saying things like 4 is congruent to 5 is not as big of a deal because I know 4 is congruent to 8. 8 and 5 are vertical angles, so they are congruent. So it kind of follows that 4 would be congruent to 5. Okay, what else would follow from this statement that corresponding angles are congruent? Well, if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. So I'm just going to keep labeling all these angles, even though we might not use all of them. So now I have same side interior angles. Well, earlier we said interior angles are angle 3 and angle 4, and then angle 5 and angle 6. Now I'm talking about the same side interior angles are supplementary. So the ones on the same side, that would be 3 and 5. Oops. And 4 and 6. And when you add those together, since they're supplementary, they add to 180 degrees. Which again follows, if 8 and 6 are supplementary, and I know 4 is congruent to 8, then it follows that 4 and 6 would be supplementary. So this is all coming from that saying corresponding angles are congruent. And yeah, we'll leave it at that for now. Okay, the last one for this, where we start with parallel lines and move to, what can I say about the angles? If a transversal is perpendicular to one of two parallel lines, so I know that, let's go ahead and let's label these lines. So let's say this is, well, I guess I can get the colors. Okay, so let's say this is line L, and this is line M, and this is line N. It's my cursive letters. Okay, I know I'm given that L is perpendicular to, to M. That's what I'm given. And I can conclude that if that's true, well, then it's also perpendicular to N. Keeping up with the colors. Easier said than done, sadly. Okay. So there you go. If L is perpendicular to M, then L is perpendicular to N. And again, you could think about these, if you think about these like we thought about our other angles, right? This angle right here and this angle right here would be congruent because they're corresponding. And you could say that for any of these 4 angles. And since they're congruent, if this is perpendicular, well, then that will also be perpendicular. So those are some basics where we start with parallel lines and we move to angles. In another segment or video, we'll talk about what happens when we start with the angles and can move to the parallel lines.